Welcome to The Explainer. Today, we are peeling back the layers of an operating system you use every single day, Windows. But we're not just going to look at the desktop. Oh no, we are going deep, deep under the hood, and we're looking at it all from a security perspective.
For anyone in cybersecurity, whether you're on a blue team, you're a threat hunter, you name it, understanding what's happening beneath that shiny user interface isn't just a nice to have. It is absolutely essential.
Because really, it all boils down to this. You just can't protect what you don't know. So let's build that foundational understanding together, starting right from the very core of the operating system. So here's our game plan. We're going to journey from the inside out. First, we'll hit the core architecture. Then we'll look at the engine, the processes and services that make it all run. After that, the blueprint for how data is stored. And finally, we'll get you set up with the investigator's toolbox and meet the system's built-in guardians. Okay, let's dive right in. The single most important concept in Windows architecture, and I mean the most important, is the separation between user mode and kernel mode. This isn't just some academic detail, it's the absolute bedrock of the entire security model. And this table just lays it out perfectly. Think of kernel mode as the system's brainstem. It has total, unrestricted access to all the hardware, all the memory. It's the VIP lounge where the most critical OS components live. User mode? Well, that's where everything else runs. Your web browser, your documents, your games, and they all have limited privileges. So if an app crashes in user mode, it's annoying, sure. But if something goes wrong in kernel mode, well, that's when you get the dreaded blue screen of death. So here's the crucial takeaway. The main goal for most sophisticated malware is to pull off something called privilege escalation. Basically, they're trying to find a weak spot, a vulnerability that lets them jump the fence from the restricted user mode into the all-powerful kernel mode. And if they succeed, they get complete control. It's game over. All right, let's move up to the next layer and see how this all connects. Now that we get the two operating modes, what's actually running on the system at any given moment?
This is a really simple but vital distinction. A process is an active application you launch yourself, like opening up Word or Chrome. Services, though, they're kind of like the invisible engine components, just humming along silently in the background. They handle all the critical OS tasks, network connections, system updates, often without you even knowing they're there.
And of course, your first window into this world is the good old Task Manager. It's a fantastic tool for a quick health check, right? You can see what's eating up your CPU, your memory, and your network resources.
But for a security analyst or a sysadmin, Task Manager is really just scratching the surface. Malicious software is designed to be sneaky. It's built to hide where you wouldn't normally think to look. So to really hunt for threats, we gotta go deeper.
And this is where the professional's choice comes in, the Sysinternals suite. A tool like Autoruns, which you see here, is just indispensable. It literally shows you every single program, every driver, and every service that's configured to start up automatically with your system. And that is a favorite hiding spot for persistent malware. Autoruns just shines a huge, bright light on all of it. Okay, so we know how Windows separates tasks and we know what's running. But now, where does it store all its data and configuration settings? Well, that brings us to the file system and the registry. You might still see the older FAT32 system on, say, small USB drives, but for any modern Windows machine, NTFS is the standard, and for a very good reason. It's not just about handling bigger files, it's all about security. NTFS introduced something called Access Control Lists, or ACLs, which let you set incredibly granular permissions on who can read, write, or execute any file or folder. It's a truly foundational security feature.
Now, this is where it gets really interesting. There's this lesser-known feature of NTFS called alternative data streams. It's a totally legitimate feature that lets a web browser, for example, tag a downloaded file with info about where it came from, but like so many legitimate features, it can absolutely be abused. And yup, this is a classic tactic for attackers. They can hide an entire malicious program inside the alternative data stream of a harmless-looking text file. It won't show up in a normal file explorer, which makes it a super stealthy way to stash tools on a compromised system. This is a perfect example of what we call a living off the land technique, where attackers use the system's own built-in features against itself to avoid being detected. Pretty clever, right? And if NTFS is the file cabinet, then the Windows registry is the system's central nervous system. It's this massive, sprawling database that stores all the low-level settings for the OS and for so many of the applications that run on it. It's another critical place that security pros look for signs of persistence and sketchy configurations. So we've seen the core layers of the OS. Now, how do we actually investigate and poke around to see what's going on under the hood? Let's open up the Investigator's Toolbox. So on the left, you've got the classic command prompt, CMD. It's been around forever. But on the right, you have its incredibly powerful successor, PowerShell. And PowerShell isn't just a shell, it's a full-on scripting environment built on the .NET framework. For automating tasks, for querying system information, for conducting forensic investigations, PowerShell is the undisputed champion today. And for the ultimate graphical toolkit, we come right back to the Sysinternals suite. These tools were created by Mark Russinovich, who's now the CTO of Microsoft Azure, so you know they're legit. These dozens of free utilities, like Process Explorer, Autoruns, Process Monitor, they give you an unmatched, deep dive view into exactly what your Windows system is doing at any given moment. Okay, finally, let's talk defense. You can't just rely on manual investigation, right? You need automated guardians. So let's cover the native security defenses that Microsoft provides to protect the whole system. Modern Windows comes absolutely packed with a powerful, layered suite of security tools. First, you've got Microsoft Defender, your real-time anti-malware bodyguard. Then there's the firewall, which is like a bouncer for all your network traffic. User Account Control, or UAC, stops unauthorized changes by asking for your permission. BitLocker can encrypt your whole drive to protect your data if your laptop gets stolen. And finally, Secure Boot makes sure nothing nasty can mess with your system before the OS even loads. And this just shows how beautifully it all comes together. The Windows Security Dashboard gives you what we call a single pane of glass to monitor and manage all of these built-in defenses. It gives you a clear and immediate view of your system's overall security posture. It's fantastic. So, after our quick tour under the hood of Windows, what are the most crucial points? The things that anyone in cybersecurity absolutely has to remember. It matters because attackers don't just see a desktop. They see an attack surface with multiple layers. The kernel, running services, the file system, the registry. So to truly defend a Windows system, you have to understand it at every single one of those layers. You have to know its architecture, master its tools, and effectively use its built-in defenses. Why? Because that is exactly what your adversary is trying to defeat.